Okay, Unit 1, we are going to discuss about the hardware and software. Okay, so first topic is what are digital devices? Digital devices contain an electrical circuit that uses discrete, that means exact, 1 and 0. There's no any number between 1s and 0. We have 0 or none, on, off. On mean 1, off means 0. Do you know analog wave and digital waves? Analog waves are like, I'll show you. Analog waves are something like this. Normal natural waves we call as analog waves. So this wave contain lots of stages from one point to another point. There are we can draw multiple stages, but this is analog. Okay, and when we consider about the digital signal, we have only 0, that is off stage, then 1 on stage, only these two stages. Between on and off, there's no any stage. Is this clear? Only two stages, on and off. So this signal is digital signal, then top one is analog signal. So natural waves we call analog signals. Digital signals mean on and off, we call digital signal. Is this clear? Then, digital device contain an electrical circuit that uses discrete exact values in its design and functions. So all the functions are also going on with on and off. These discrete values are usually zeros and one. You have probably heard this system of notation based on only two possible values. What do you call binary? We call binary numbers. If the number contains ones and zeros, we call binary numbers. So binary numbers base 2. So binary numbers are base 2 and we get 0 or 1 values. So if I write it 1, 0 base 2, so this value we call number 1, 0. I'll just write 1, 0 base 2. I think when you were in grade 8, you have done the 2 to the power 0, 2 to the power 1 values for this and converted this binary number into decimal. 2 to the power 0 mean 1. 1 multiplied by 0 mean the value is 0 here for this one. And this one 2 to the power 1, 2. 2 to the 2 multiplied by 1, then value is 2. So after that we add both. So final answer will be 2. This 2 we can represent in decimal. So 1, 0 binary is equal to decimal 2. Is this clear? Then when you were in grade 9, same thing you have done. 8. Okay. In grade 8, can you remember? You got a number something like 7 base 10, ask you to convert into binary. Base 2. So 7 divided by 2, you got 3 and 1 remain. 3 divided by 2, you got 1 and 1 remain. 1 divided by 2, you got 0 and 1 remain. All the remains you wrote together as answer, as the answer. 1, 1, 1 base 2 was the answer. Can you remember those? So what I did here, decimal to binary I converted. D to B, decimal to binary I converted. Earlier what I did, binary to decimal I converted. Okay. So actually what is digital device? The devices which are contains ones and zeros we call as digital devices. So those devices has discrete values, ones or zero. So we call the system contains binary numbers. Okay. Then, okay, shall we note down that? Now we are going to convert binary 110 into decimal. So when we simplify it, take the 2 to the power 0 here. Here, this is the 2 to the power 1, 2 to the power 2. 2 to the power 0 means 1. 1 going to multiply by 0 plus 2 to the power 1 means 2. 2 multiplied by 1. Then 2 to the power 2 means 4. 4 multiplied by 1. Add all the values. We have 4 plus 2 plus 0 is equal to 6. Base 10. Check whether you have written the base 10. Okay. So now we'll see the note again. Digital devices. The digital device contain an electrical circuit that use discrete values. It designs and functions. The discrete values are ones and zeros. One mean on, off mean 0. Then binary numbers devices contain binary number systems devices contain ones and 0, which contain digital signals. Digital signals contain 2 stages such as on and off. Therefore, we call digital signal contain discrete values of 1 and 0. But natural waves are called analog signal, which contains many values between 2 points. Therefore, we call analog signals are not discrete. Then
for the range between 2 and 1.
each sine, that is sine wave, if we consider 2 points, between that 2 points, there are multiple values. Therefore, we call sine waves are not, analog waves are not discrete. Okay, but digital signals are discrete. It contains 0, 1, that means off and on stage. Another important thing, this on stage or as one stage is not actually voltage 1. Okay, it is a higher voltage. We call high. Okay, and down one is lower. This is some kind of voltage difference. So 0 voltage and 1 voltage also can call, but 0 is not actual 0. Close to 0. Lower voltage. 1 mean higher voltage. This position may be in the graph, it may be 10 voltage. And this may be 2 voltage. 0 may be 2 voltage. But higher mean on, 0 mean lower. Okay, so higher voltage and low voltage we can call as 1 and 0. 1 mean higher one, lower mean 0, 1. It is not the exact 0. In the special cases there may be, but it is not exact 0. Why? If the machine is going to switch on and off, will it work? 0 mean ground, ground mean earth. Ne? So if the computer is always going to off, on, off, on, off, on, will it work? No. High voltage to low voltage. So it may be plus 5 and minus 5. Okay, not the exact 0. Higher voltage and lower voltage. So higher voltage we call 1, lower voltage we call 0. Is it clear?
So the battery is something related. Battery is something related.
So alternative, no, that means battery, not the normal batteries. Ne? So computer is giving us, with the power pack, we get the digital signal. So therefore, we change that voltage and take it. Not the analog signal. When we are charging even, there is a small box here. Okay, so this box gives us the required amount of voltage, higher and low voltage, not the direct 240 voltage which we take from the normal plug basis. Okay, so it convert according to our requirement. So normally power packs are using, but computer charge, laptop charges, it comes with this one. Okay, so we are going AC DC current. Do you know DC current? Discrete current. So AC analog current. Okay. So we convert and get the required one according to our requirement in our machines. Okay. So then we convert binary numbers into digital, binary numbers into decimal. So binary numbers contain the place values 0 to the power 0, to the power 1, to the power 2, like that. So we'll get another number, number 7. So number 7 we can convert into binary by dividing 2, then 3, 1 remain, 3 divided by 2, 1, then 1 remain, 1 divided by 2, 0, 1 remains. So the remains down to top, we write 1, 0, 1. I'll give you one question. Take 25. Convert the decimal decimal 25 into binary. Divide it by 2.
You have put 110 below.
Ah,
The answer is correct. No, no, I mean,
okay, so number is 25. 25 divided by 2, 12. So inside 25, there are 12 two groups, one remains. So take the 12 and divide by 2. 6 groups are there and 0 remains. Take the 6 divide by 2. 3 groups are there, 0 remains. Take the 3 divide by 2. 1, 1 group and 1 remains. So 1 divide by 2, 0 groups and 1 remains. Take from the bottom to top, 1, 1, 0, 0, 1 base 2. So now by looking this one, you can convert it the other side also. You can check your answer. How? First one is 2. Sorry. First one 1, 2, 4, 8, 16. 16 plus 8, 24. 24 plus 1. Yes. 2 to the power 0, 1. Okay. 2 to the power 0. We are going to find what is the value of. I'll give all together. 2 to the power 0. What is 2 to the power 0? 1. Very good. 2 to the power 2. Sorry, 2 to the power 1, 2. Then 2 to the power 2 equal 2 multiplied by 2. Right like that. Equal 4. Next one, 2 to the power 3. What is the answer? Very good. 2 multiplied by 2 multiplied by 2. 8. 2 to the power 4.
16.
2 to the power 5.
30.
2 to the power 6.
60. 20.
2 to the power 7. 128. 2 to the power 8.
256.
2 to the power 9. 500. 2 to the power 10.
1000.
1024. Is this clear? Then 2 to the power 11. 2000. Okay. Shall we move to the next section then? Classification of computers. We are going to classify computers according to the types.
2 seconds.
Okay, so we are going to classify the computers according to mainly 3 types. First one, based on the computer types, whether it is analog signal, digital signal, or hybrid computers. Some computers are containing only analog signals, where in hospitals, ECG, okay, so where that some scanning, so they are using analog signals. Then digital computers mean the devices what we are using today. And hybrid computers mean both analog and digital signals are used. So scientific experiments and hospital, they are using analogs, as well as hybrid are using in scientific experiments also.
What about
Is
digital?
digital or everyone using digital? Okay. So next one, based on the purpose. So my machine is okay. So next, based on the computer purpose, we can categorize the computers. So general purpose, our machines are general purpose computers. In hospitals, there are special purpose computers. Then next one, based on the size. Microcomputer is normal desktop computer. Then mini computers, tablets also there. Then mainframe computers. Mainframe computers mean large computers which available in the SLT or internet service providers. Very powerful computers like server computers. Supercomputers like Google, that mean very large companies containing supercomputers for some scientific experiment as well as server side, both side. Okay, so supercomputers are the powerful, more high powerful computer. Okay, so those are the mainly 3 category classifications of the computer based on the type, based on the purpose, based on the size. Is that clear? Shall we draw the chart? I'll draw the lines there, then easy for you. Okay, classification of computer. I can draw 2 lines like this and like this. Then this one dividing into like a short note. It's better to have it. Ne? Just the structure. Because now we totally change it. Copy down this sample. Okay, so digital around the world in April 2020. The population, the essential headlines, data you need to understand mobile internet and social media. So population 7.7 billion, then urbanization 50%, 55%. Then 5 point that mean digital devices are using uh, lots of people that time. Then um, unique mobile phone users are 5.16 billion, percentage 66%. Then internet users 4.57 billions, percentage we can take 59%. Then active social media users 3.81 billion, then 49%. But this is before the COVID. After 2020, okay. So if we analyze now, it exceed more than 90%. Not 90 and it will somewhere around 100%. Okay, so we always online with the social media. So actually this is outdated. No need to copy this one. Okay. Next one. Okay, this is a nice story. Data storage capacity. When we were small, we saved the data into floppy disk. The floppy disk was the highest capacity that time. It was the 1.4 megabytes when I was in grade 10. Okay, so when the teacher asked us to save and bring some Word document with the clip art, small images, okay, not like today. So we could be able to save in that floppy disk. The capacity was 1.4 megabytes. But assume today, can you save a document in such a small size? Can't. It is outdated. Now it's not no longer, we are not going to use it. Then after a certain period of time, CD-ROMs came, then that is 200 megabytes that days, not today. Then DVD 4.7 gigabytes. Blu-ray now around 60 GB is available, 64 GB. So now the range has given 25 GB to 128 GB. Hard disk 8 GB. Magnetic tape up to 158 TB. But now magnetic tapes also not going to use. 3 years back, magnetic tapes used in the bank sectors, but now